Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartural.it/Jedi. I offer some product information and products for preparation for actuarial exams. I'm in the process of revising the manuals for MFE and MLC into manuals for IFM and LTAM. So when those are ready, I'll be giving you links here to those, but right now you can get my manuals for P and FM. And I direct the actuarial program at Illinois State University. You can find information about it at smartural.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartural.it/help ISU actuary. Here's a problem for today for exam P on probability. A company is reviewing tornado damage claims under a farm insurance policy. Let X be the portion of a claim representing damage to the house and Y be the portion of the same claim representing damage to the rest of the property. The joint density function of X and Y is f of xy equal to 6 times 1 minus quantity of x plus y for x greater than 0, y greater than 0, and x plus y less than 1, and 0, the density is 0 otherwise. Determine the probability that the portion of a claim representing damage to the house is less than 0.2. So damage to the house is x, and we want the probability that x is less than 0.2 given this joint density. Here's a solution. So for a problem about two-dimensional distribution where you're considering the relationship between random variables typically denoted by x and y, you should start your solution by drawing a graph of the area where the joint density is positive and then where events considered happen, the event whose probability you're calculating. The area where the joint density of x and y is positive is shown in the figure below as the triangle bounded by the axis, x-axis and y-axis, and the line y equals 1 minus x below that line, because below that line x plus y is less than 1. And then the shaded region is the portion of the domain of the joint density where x is less than 0.2, because you see that that's to the left of the value of x where x is 0.2. And then the probability that x is less than 0.2 is just the double integral over that region where x is less than 0.2 of the joint density. So it's the integral for x running from 0 to 0.2, and then y running from 0 to 1 minus x, because y has to be less than 1 minus x of the joint density, which is 6 times 1 minus a quantity x plus y. And then we take the integral with respect to y first, and then with respect to x. And after we take the integral with respect to y, 6 is a constant, so we just put it in front. And inside we have y minus xy minus 1/2 y squared, evaluated from y equal to 0 to y equal to 1 minus x. So at 0, it's 0, and then at 1 minus x is what you see here. So it becomes 6 integrals from 0 to 0.2 of 1 minus x times 1 minus x minus 1/2 of 1 minus x squared. And then 1 minus x can be factored out from the first two expressions. And once you do this, you see that what you get is another 1 minus x. So it becomes 1 minus x squared minus 1/2 of 1 minus x squared. So the whole thing simplifies to 6 integrals from 0 to 0.2 of 1/2 of 1 minus x squared dx, and the integral of that expression, 6 times 1/2 is 3. So we can just put that 3 there and realize that if we have 1 minus x cubed, then when you take the derivative of that, you would put 3 in front. And that 3 is already there. So we almost have the derivative of 1 minus x cubed there. almost, because the derivative of minus x is negative 1, so you need that minus to cancel that negative 1. So the integral of 3 times 1 minus x, the quantity of 1 minus x squared, is minus 1 minus x cubed. And we evaluate it from 0 to 0.2. And that becomes minus 0.8 cubed plus 1. And that is equal to 0.488, which is answer C. Please remember that this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.